messy here, but we got to give everybody that 3 first. So that's 2 to the third, x to the 3/4 to the third, y to the 1/3 to the third. And we might as well deal with this negative as well and bring that up. So we have times y to the 4th, x to the 1/2. Okay. So we'll clean up 2 to the third is 8. When I multiply these, that is what, 9/4? This is just straight multiplication. So we have an x to the 1/2, we have a y to the 4, and then the denominator, 1/3 times 3 is 1. Okay, so now we just have to clean up a bit. The 8 is going to stay. The x's can add together. So 9/4 plus 1/2 is going to give us 11/4. And then the y to the 4th on top with the y to the 1st makes just a y to the 3rd. Okay. Simplifying by writing radicals as rational exponents. So in this case, we want to leave everything as a rational exponent. So we're going to see those fractions. Okay, so it may be helpful to just first change any radical we see into a fraction. So we have 2 times. The square root of x is like x to the 1/2, right? It was technically to the first power, and there's like a little hidden 2 out here, so 1/2 times 3 times, again, this x is technically to a 1, so that's the 1/3. Now I can multiply 2 times 3 and get 6, and then I'll add these exponents together, so 1/2 plus 1/3 is going to be 5/6. Okay. The next one, a little bit crazier. This big square root means the 1/2 power. This guy is just an x. And this guy is another x to the 1/2. Okay, let's clean up on the inside. This guy really had a 1 as the exponent, so I can add these two together. That's x to the 3/2. And then I'll multiply together, and that'll give me x to the 3/4. Sometimes we're asked to rationalize the denominator. So when we are asked to simplify, most of the time what we mean is we do not want to see a square root in the denominator or a cube root, fourth root, whatever root. We don't want to see a radical symbol in the denominator. Now, when you get to pre-calc, when you get to calculus, sometimes there are times that it is okay or necessary in order to kind of work backwards through a problem. However, for our purposes, unless the directions say to rationalize the numerator, you will always want to leave the denominator without a radical. All right, so let's just hop into some of these problems, and you'll see what all these symbols on the page before meant. So if you remember from Algebra 1, if I want to rationalize 2 over root 3, what I'm going to do is multiply by the square root of 3 over the square root of 3. The reason I am allowed to do that is because this is equivalent to the number 1, and when I multiply by 1, it does nothing. Well, to the value of it, I should say. It does make it look different, but it's not going to change the value. So 2 times root 3 is just 2 root 3, and the square root of 3 times the square root of 3 is the square root of 3 squared, right? Remember, we multiply the 3 times 3 underneath. So that will cancel out in the denominator, and I'll get the 2 root 3 on top over 3, because the radical and the 2 cancel. We're going to use the same logic to do a cube root. So we have 1 over the cube root of 5. Now, if I just say I'm going to multiply by the cube root of 5 over the cube root of 5, that's fine, except that doesn't fix things for me. Because what that's going to do is give me the cube root of 5 squared in the denominator. Cube root and squaring do not undo each other. What does undo each other, though? Cube root and cubing. So what would I have to do to make sure I get 5 cubed under the radical? Well, I already automatically had a 5 to the first here. I would have to make sure I multiply by 5 squared, because the 1 plus 2 gives me this 3. So whatever I do to the denominator, I'm doing to the top, so that that fraction is like multiplying by 1. All right, so in the top, that is the cube root of 5 squared is 25. Technically times 1. And then in the denominator, the cube root and the cube cancel, which was the whole point of doing this, and I just get the 5. Okay. And then in C, we have a little bit messier, but it's the same concept. So sorry, that's my dog sighing in the background. The 5th root of 5x squared. Okay, so we want to multiply by something. The 5th root of 5 to the something and x to the something. And the whole point of this is that when I do this, I want to make sure I end up with 5 to the 5th power and x to the 5th power, because if I do that, then when I go to simplify, I will just have a 5 and an x in the denominator. So what would I need to use for the exponent for the 5? Well, I already had a 5 to the 1st, so I need 4 more of them to make that a 5th power. I already had x squared, so I need 3 more to make that, whoops, that's a terrible 3, to make that a 5th power. So really what I'm doing is multiplying by the 5th root of 5 to the 4th, x to the 3rd. Okay, and let's see, that's going to be a little bit messy. Let's see, 5 to the 4th, that's 25 times 25, 625. So we'll have the 5th root of 625 x to the 3rd. And we were just multiplying by 1. If this was another number, we would have to also include that in the numerator.